You could write device applications with C or C++, but the result would be specific to a single platform. An application written using the MIDP APIs will be directly portable to any. Does MIDP deliver painless cross-platform functionality? Yes. There will always be platform-specific bugs in MIDP implementations, but we believe MIDP works as advertised because it is so much smaller than desktop Java. Less code means fewer bugs when porting to multiple platforms. MIDP has nothing approaching the complexity of AWD, which means there's an excellent possibility that MIDP applications will seamlessly run on multiple platforms right out of the starting gate. Furthermore, while the JDK 1.0 test suite only included a few dozen tests, the MIDP compatibility test suite includes several thousand tests. There are three classifications in mobile applications. First one is browser-based. That means application or services developed in a markup language. Then native compiled applications. Device has a runtime environment. Interactive apps such as downloadable games. Finally, hybrid, the best of both worlds. A browser is needed for discovery. The second revolution is the explosion of small device Java, and it's happening now. The market for small devices is expanding rapidly, and Java is important for two reasons. First, developers can write code and have it run on dozens of small devices, without change. Second, Java has important safety features for downloadable code. A profile is a collection of APIs that supplement the configuration to provide capabilities for a specific vertical market. PLDC standards for connected limited device configuration. It defines APIs and JVM capabilities. APIs are subset of Java Southeast, Java.Ling, Java.Util, Java.io. Also defines connectivity framework, javax.microedition, IO, but implementation left for profiles. Small devices range in size from pagers, mobile phones, and personal digital assistants, PDAs, all the way up to things like set-top boxes that are just shy of being desktop PCs. JTME is divided into configurations, profiles, and optional APIs, which provide specific information about APIs and different families of devices. A configuration is designed for a specific kind of device based on memory constraints and processor power. It specifies a Java virtual machine, JVM, that can be easily ported to devices supporting the configuration. It also specifies a strict subset of the Java 2 platform, Standard Edition, Java Southeast, APIs that will be used on the platform, as well as additional APIs that may be necessary. Device manufacturers are responsible for porting a specific configuration. Given the spectrum of configurations and profiles, MIDP comes at a critical time, a time when MIDP devices, like mobile phones, are an exploding market. Simultaneously, MIDP devices are achieving the kind of processing power, memory availability, and internet connectivity that makes them an attractive platform for mobile networked applications. MIDP is already deployed on millions of handsets all over the world. Second, of course, MIDP is the first JTME profile that is ready for prime time. KVM. KVM stands for Kilo Virtual Machine. It is a complete runtime environment for small devices. Originated from a research project called Spotless at Sun Research Labs, implements the classes defined in the PLDC specification. Midlet Suite Security. Wireless application security is important to almost everyone involved in the wireless industry. Carriers want to be sure that viruses do not bring down their customers' devices or their networks. Device manufacturers don't want customer-installed software crashing their devices. Users want to be able to run downloaded code without threatening the stability of their device or the safety of their personal information. Additionally, they may want control over the network usage of their applications, as network usage often costs money. Application developers do not want their applications to be compromised by other applications. When used to describe hardware, portable means small and lightweight. A portable computer is a computer small enough to carry. Portable computers include notebook and sub-notebook computers, handheld computers, laptops, and PDAs. When used to describe software, portable means that the software has the ability to run on a variety of computers. Portable and machine independent mean the same thing, that the software does not depend on a particular type of hardware. You could write device applications with C or C++, but the result would be specific to a single platform. An application written using the MIDP APIs will be directly portable to any. Does MIDP deliver painless cross-platform functionality? Yes. There will always be platform-specific bugs in MIDP implementations, but we believe MIDP works as advertised because it is so much smaller than desktop Java. Less code means fewer bugs when porting to multiple platforms. MIDP has nothing approaching the complexity of AWD, which means there's an excellent possibility that MIDP applications will seamlessly run on multiple platforms right out of the starting gate. Furthermore, while the JDK 1.0 test suite only included a few dozen tests, the MIDP compatibility test suite includes several thousand tests. Security. A second compelling reason for using Java for small device development is security. Java is well known for its ability to safely run downloaded code like applets. This is a perfect fit. It's easy to imagine nifty applications dynamically downloading to your mobile phone. But it's not quite such a rosy picture. For one thing, the JVM used in the PLDC only implements a partial bytecode verifier, which means that part of the important task of bytecode verification must be performed off the MIDP device. Second, the PLDC does not allow for application-defined class loaders. This means that most dynamic application delivery is dependent on device-specific mechanisms. MIDP applications do offer one important security promise: they can never escape from the confines of the JVM. This means that, barring bugs, an MIDP application will never be able to write to device memory that doesn't belong to the JVM. An MIDP application will never mess up another application on the same device or the device OS itself. This is the killer feature of MIDP. It allows manufacturers and carriers to open up application development to the world, more or less free from certification and verification programs, without the fear that rogue coders will write applications that crash phones. In MIDP 2.0, midlet suites can be cryptographically signed, and then verified on the device, which gives users some security about executing downloaded code. A new permissions architecture also allows the user to deny entrusted code access to certain API features. For example, if you install a suspicious-looking midlet suite on your phone, it will only be able to make network connections if you explicitly allow it to do so.